All right, so to begin this next module, we're going to do a review on slope. Our goals, I know what slope measures, I can find the slope of a linear graph, and I can find the slope given two coordinates. This is our goal, to be able to say all three of those. Okay, slope measures the steepness and direction of a line. In everyday life, we see slope in wheelchair ramps, ski slopes, and roofs. In mathematics, slope is defined as a ratio of the vertical change to the horizontal change. So, slope is the ratio of the vertical change called the rise to the horizontal change called the run. So, we use the variable m in mathematics to represent the slope. Don't know exactly why, but that's what we do. Okay, slope is the ratio of the vertical change. So once again, rise over run, and m represents the slope in mathematics. So rise over run. Okay, there are four different types of slopes. First off, we have a positive slope, which it says as x increases, y also increases. So that means as x goes this way, y goes this way. So that's why it's a positive slope. So a line goes up from left to right. Next, we have a negative slope. As x increases, y decreases. So that means as I'm going to the right, my line is going to be going down, which is why I have that negative slope. We also have something called the zero slope. The line is completely horizontal. Or you could say flat. Okay, so it's just a line that's laying down completely flat, nothing's happening. That means you have a zero slope. And then last, we have something called an undefined slope. Okay, undefined slope means the line is completely vertical. Or it's standing up. Okay, so if it's standing up, it is known as an undefined slope. There is rise, but there's no run. Whereas the zero slope, there is no rise, but there is run. So we got the zero slope, undefined slope, negative slope, and positive slope. Those are our four different types of slopes. So if they give us a graph and they ask us to find the slope, we're just going to do the rise over run. I always work from left to right. Almost always. I shouldn't say always. I just feel like it's easier that way. So I find a point that they identify a point on the grid. And then from that, I'm going to make my way to the point I find on the right. So the rise, how much do I go up? I go up 1. So my rise is 1. And how far over do I go? I go 1, 2. My run is 2. So rise over run means I have a slope of 1/2. So I'm just counting how much I go up or down and how much I go right. So over here, I'm going to start at this point and I'm going to end up at this point. So my rise, I go 1, 2, 3, 4. So I went up 4 and I go right 1. So if the slope is rise over run, over here I have 4 rise and 1 for the run. So I have a slope of 4 over 1, which is the same as just saying a slope of 4. Because 4 divided by 1 is 4. So that's how I find the slope if it's just on a graph. Let's look at this one. So I'm going from this point to this point. This time my rise is actually going down. So I'm going down 1, 2, which means I make that as a number. I say -2. Down 2 is -2. And I'm going to the right 1, 2, 3, 4, 5. I went to the right 5. So my run was -2. Sorry, my rise was -2. and my run was 5. So I have a slope of negative 2/5. Okay, so 1, 2, 3, 4, 5, 6, 7. I dropped 7. So my rise is negative 7. And I'm going to the right. 1, 2, 3, 4. So my slope over here is negative 7/4. Okay, so your slope is just telling you your rate of change. I'm going down 7, right 4. And that just repeats that over and over again. I keep going down 7, right 4, down 7, right 4. And I will always be on the line because that is the constant change. It's the slope. Okay, here. So I'm going from here to here. Okay, what is my rise? My rise is 0. It doesn't go anywhere. My run is 1, 2, 3, so it's 3. 0 over 3. This is a flat line. Remember, we learned that the flat horizontal line means it has a slope of 0. And mathematically, 0 divided by 3 is 0. That's why it works out that way. Now over here, we have a rise of 1, 2, 3, 4, 5. A rise of 5 and a run of 0. It doesn't run anywhere. So it's a vertical line. Our run is 0. We can't divide by 0 in math. So that is why this slope is undefined. It's not possible. It doesn't have one. It's undefined because I can't divide by 0. Okay. Now, what if I don't have the graph and all I have is a couple coordinates? Well, there's a formula that helps us. Okay, so we have the vertical change, which we find 2 points, and we find the difference between the y's, so y2 minus y1, and we divide it by the horizontal change of those 2 points, which is just subtracting your x's. So I could get 1 point, and we would call it x1, y1. And we get a second point from the graph. We call it x2, y2. And then we just plug it in this formula. Because it helps us find the vertical change, or the rise. And it helps us find the horizontal change, otherwise known as the run. So even if we can't visually see the graph, if they give us 2 points that are on that linear graph, we can figure out what the slope is. Okay, so let's say we have a graph that goes to the coordinates 3, 2, and 7, 8. All right, so I'm going to call this x1. I'm going to call this y1. That's my first coordinate. My second coordinate, I'm going to call it x2, y2. So we're just going to simply plug it in to our formula to help us find the rise and the run. So y2 would be 8 minus y1, which is 2, over x2, which is 7, minus x1, which is 3. So 8 minus 2 is 6. That's my rise. 7 minus 3 is 4. That's my run. 6/4 can be simplified, so let's simplify if we can. That equals 3/2. So I have a slope of 3/2, which means it is a positive slope. So I'm going up 3, right 2. And then up 3, right 2. And over again, up 3, right 2, because that is my slope. Okay, let's try it on another one. Here's 2 points. All right, let's say this is my x1. This is my y1, which means this is x2 and y2. Okay, so y2 is negative 4 minus y1, which is 5, over x2, which is 2, minus x1, which is negative 1. Now, sometimes to help myself, I put parentheses around all the stuff that I plug in, because it helps me realize what numbers I'm subtracting. So here, negative 4 minus 5 is a negative 9. Down here, 2 minus negative 1. Remember, when you minus a negative, it's like adding. So this essentially turns into a plus. 2 minus negative 1 is 3. So if it helps, if I went back to this problem, I would have put my 8 in parentheses and my 2 in parentheses. 8 minus 2 is 6. I would have put my 7 in parentheses and my 3, and 7 minus 3 is 4. So I use parentheses all the time when I plug things into formulas. I think it's a great help. So back to this problem, negative 9/3 simplifies to negative 3. So I have a negative slope of 3. Okay, negative 2, 6 and 2, 6. All right, first coordinate gives me x1, y1. Second coordinate gives me x2, y2. So y2 is 6. Subtract y1, which is 6, over x2, which is 2, minus x1, which is negative 2. Okay, so think of it like this. I'm putting the parentheses around these to help me distinguish what the numbers are that I'm subtracting. 6 minus 6 is 0. 2 minus negative 2 is just like 2 plus 2, so it's 4. 0 divided by 4 is 0. That means that this is a flat line. So it doesn't have any rise or run. Or sorry, it doesn't have any rise. It has a run, so it rises 0 and runs 4. So we just have a flat line. That's what that means. All right. And then if you ever get one like this where 0's on the bottom, remember you can't divide by 0, which means your slope is undefined. It's a vertical line, straight up and down. So I know what slope measures. I can find the slope of a linear graph, and I can find the slope given two coordinates. We've gone over all three of those. Go ahead and work on your assignment, and go ahead and reach out if you have any questions for me.